Alrighty, let's do a little bit of a midterm review here that will hopefully not only enhance learning, but get us prepared for the first exam that will be tomorrow. So what I'm going to be doing is looking at the KSU summer 2019 Math 551 exam 1 here. This should be the only exam that I have published in our files that doesn't have a solution set with it. And so I wanted to kind of go through that exam here, and this video will serve as the solution set, but also as a review. Okay, so the first problem that we want to do is we want to solve the following system. We have, let me use smaller font here. So we have x1 plus 2x2 minus x3 plus x4 equals 3. And then we have x1 plus x2 minus x3 plus x4 equals 1. And then lastly, we have x1 plus 3x2 minus x3 plus x4 equals 5. And now there are a bunch of parts to this question, and I'll address the answers to some of those parts. But a lot of the parts here is just solving the system of equations. So I'm not going to really address part by part here. Let's just solve this system of equations. And it asks us to do this using an augmented matrix that represents this system of equations. Well, if you'll remember, we can represent a system of equations by the equation ax equals b, where here A is going to be the coefficient matrix. So in the first column, we take all the coefficients of x1. So 1, 1, 1. In the second column, we take all the coefficients of x2. 2, 1, 3. X3 is going to be negative 1, negative 1, negative 1. And then x4 is going to be 1, 1, 1. Right? X here is going to be the vector that we're solving for. So this is going to be the vector x1, x2, x3, x4, and b is going to be the constants on the right side of the equality. So this is going to be the vector 3, 1, 5, right? And so what does it mean to set up an augmented matrix representing this system? Well, we know an augmented matrix is some matrix M that equals A augmented B. And so let's set up this augmented matrix first. The augmented matrix that we are going to get for this particular system is 1, 1, 1, 2, 1, 3, negative 1, negative 1, negative 1, 1, 1, 1, and then 3, 1, 5. This is our augmented matrix, right? And now how do we use an augmented matrix to solve a system of equations? Well, what we have to do is we have to put this augmented matrix in reduced row echelon form. And so let's do that. How do we put things in reduced row echelon form? Well, we start in the leftmost column, right? And we want to make all entries below that 1 a 0. So we want to make these entries a 0. That's our first step. So how could we do that? Well, we could do that by saying, let's replace row 2 by row 2 minus row 1. And then if we wanted to make a 0 in the row 3 spot for the leftmost column, we could say row 3 is going to be replaced by row 3 minus row 1. Let's see what the matrix looks like after these row operations. Well, the first row was unchanged. 1, 2, negative 1, 1, 3. And then we have row 2 is row 2 minus row 1. So we'll have 1 minus 1 is 0. 1 minus 2 is negative 1. Negative 1 minus negative 1 is 0. 1 minus 1 is 0. 1 minus 3 is negative 2. Now let's do the same thing for row 3. We've said row 3 is now going to be row 3 minus row 1. So we have 1 minus 1 is 0. 3 minus 2 is 1. Negative 1 minus negative 1 is 0. 1 minus 1 is 0. 5 minus 3 is positive 2. Now, if you'll notice, that row 2 and row 3 are the same vector, right? The same row vector up to a negative sign. And so for that, our next step here would be to say, let's let row 3 be row 3 plus row 2. If we had row 3 as row 3 plus row 2, well, then what we would get for row 3 is a row of all zeros, right? Because we would have 1 minus 1, which is 0. So -1, 0, 0, -2, right? And then we have 1 minus -1 is 0, 0, 0, 2 minus 2 is 0. Now, we could go one more step here to put this in, or a couple steps to put this in reduced row echelon form. I'm going to go ahead and multiply through row 2. Let's say row 2 is now negative row 2. And so our matrix becomes 1, 2, -1, 1, 3, and then 0, 1, 0, 0, 2, and then 0, 0, 0, 0, 0. Okay. Well, now the last step here to put this in reduced row echelon form would to say, what do we need to do, right? We have zeros below the pivot entries. Well, now we need zeros above the pivot entries, which means we need to get this 2 to somehow be a 0. And so what we can do is if we were to say row 1 is equal to row 1 minus 2, row 2, that would do the trick, because then we would have 1 minus 0 is 1, 2 minus 2 is 0, and then -1, 1, and then we're going to have 3 minus 4, so -1, and then 0, 1, 0, 0, 2, 0, 0, 0, 0, 0. And this is now in reduced row echelon form, right? And what does this tell us? Well, let's read off the first line of this reduced row echelon form. This says x1 minus x3 plus x4 equals -1. The second line tells us that x2 equals 2. And then the third line tells us that 0 equals 0. And here, this means we have 2 free variables. And what are those free variables? That's x3 and x4, right? Because we have that these two equations explicitly determine the solutions, but there's no restriction on x3 or x4. And so how we would write the solution for these free variables is, let's say x3 is the parameter s and x4 is the parameter t for s and t real numbers, right? These are our free variables. These are our parameters. So then what is the solution set here? X. Well, it's going to be for x1, it looks like, well, if we had x1, that's going to be 1, or let's say, sorry, because that should be a -1, right? Because of the negative here, this should be a negative. So sorry for the small typo there. This would be x1 equals x3 minus x4 minus 1, which is s minus t plus 1, right? And so here we have s minus t plus 1. x2 is 2, and then x3 is s, and x4 is t. These are all solutions for s and t in the real numbers. And let's make some observations here. There's an infinite number of solutions, so infinitely many solutions here. What else do we want to notice? We want to notice that x1 and x2 are what are called pivot variables, right? Because those are the variables corresponding to a pivot position. And that means the other variables, x3 and x4, we already noticed that these are free variables, right? And then we have one uniquely determined. x2 is uniquely determined here. Okay, so this is how this first problem would be solved. When you're looking at like, oh, here's a system, solve this system by creating an augmented matrix. modify that matrix into a reduced row echelon form of itself, and then use that reduced row echelon form to determine what the solutions would be. Okay, let's look at the next problem here. The next problem here is balancing a chemical equation. So what I'm going to do for this problem is, because we just saw an example of how to solve a system of equations using writing the system in a corresponding augmented matrix, et cetera, what I'm just going to do for this one is I'm not actually going to work out the solution, but what I'm going to do is all of the setup, right? And so we're going to do most of the setting up the system, but now we hopefully are comfortable with solving these systems, right? And so let's look at the next problem here. We want to balance the following chemical equation. We have X1 FeSO4 plus X2 KMnO4 plus X3 H2SO4. And this reacts, and you get X4 Fe2 SO4. And we have 3 SO4 molecules there, plus X5 Mn SO4 plus X6 K2 SO4 plus X7 H2O. All right. Now, how do you get a system of equations from this reaction here? Well, if this is balanced, you have the same number of atoms on the left as on the right. And so that means, for example with Fe here, right? We need the same amount of iron atoms on the left as on the right. And so what does that mean, right? We would need X1, because there's 1 iron in the first term, there's none in the rest. This needs to be equal to, on the other side of this reaction here, after the reaction, here we have 2 irons, right? And so we would need this to be equal to 2X4. And then I don't see iron anywhere else in the reaction. And let's go to the next one. So here we have S, which is sulfur or sulfate or something. Off the top of my head, I don't remember. But anyway, here we have 1 S there in the first term, none in the second. Then we have 1 in the third, so X1 plus X3, and this needs to be equal to, now notice there is S in the SO4 here, but there's 3 of the SO4, which means really we have 3X4, and then plus X5 plus X6, right? Because we have S in the X5 term and the X6 term. Okay, what next? Let's do oxygen next. Well, in the first term, we have 4 oxygen, so 4X1 plus, we have 4 oxygen in the second, so plus 4X2. We have 4 oxygen in the third, so plus 4X3, and this needs to be equal to, and now we have 4 oxygen in the SO4, but we have 3 SO4s, which means really we have 12 oxygen. So this is going to be 12X4, and then plus 4X5, plus 4X6, and then plus X7, right? And so hopefully we're getting the idea here. Let's go to the next one. It looks like potassium is the next element we have here. And so where do we see K in these equations? Well, we have an X2 in the second term, and then 2. So that's going to be equal to X to the 6. Those are the only 2 terms here where potassium shows up, right? We have 1 X2 and then 2 X6. Okay. We have manganese next. So Mn is we have 1x2 there. And then I don't see it anywhere else except x5. So we have the x2 is equal to x5. Those kinds of equations are nice when you're dealing with a system of equations because basically you get to get rid of one variable, right? And lastly, what do we have? I think lastly we have hydrogen. And for hydrogen, it looks like we're going to get 2x3. Right? So 2x3, and then that should be, looks like 2x7, which tells us that x3 is equal to x7. So those help us at the end there. So now let's write out what our system of equations is to, like, solving this system will balance this chemical reaction. So we have x1 equals 2x4. We have x1 plus x3 here. I'll write it down. I have it written here. So x1 plus x3 equals 3x4 plus x5 plus x6. And then we have 4x1 plus 4x2 plus 4x3 equals 12x4 plus 4x5 plus 4x6 plus x7. That equation is brutal. Then we have, it looks like we got x2 is equal to 2x6. And then we have x2 equals x5. And then 2x cubed is equal to, well, x cubed. How about let's simplify and go ahead and divide. So we have x3 equals x7. And so solving this system will give you a solution. And in fact, it looks like this is going to give you infinitely many solutions because of, well, already looks like we have 2 free variables, right? So because of that, you're going to get infinitely many solutions, and you can find the smallest integer solution from those infinitely many, right? You just like pick the values x5 and x7 such that you get the smallest solution or whatever. What we could also do here, if I would almost recommend not solving this with a matrix, excuse me. I would almost recommend not solving this with a matrix and maybe just direct substitution here, because this seems to not be too bad, right? Because here you could just say x1 is 2x4, x2, well, x3 is x7, and then we know x5 is x2 and x6 looks like it would be 1/2 x2, right? And I would just keep going via substitution here, because let's see what this looks like when you write out the augmented matrix for the system. And what I'm going to do is I'm going to start writing this as a homogeneous system, which means the top equation would look like x1 minus 2x4 equals 0. And then x1 plus x3 minus 3x4 minus x5 minus x6 equals 0, et cetera, right? If you write this as a homogeneous system, or a system where every equation is set equal to 0, this would be the following matrix. You'd have 1, 0, 0, negative 2, 0, 0, 0, 0, 0, 1, 0, 0, 0, negative 2, 0, 0, 0, 1, 0, 0, negative 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, negative 1, 0. And then you would have 1, 0, 1, negative 3, negative 1, negative 1, 0, 0. And I realize this is slightly out of order. Like when I wrote them down, just going through the problem myself, I wrote them down in a different order than what I have here. So really what I've written over here is like after you swap some rows around. Basically what I did was I wrote the complicated ones at the very bottom. So I just wrote these two at the very bottom, right? I just wrote those at the bottom, and then the last row here would be 4, 4, 4, negative 12, negative 4, negative 4, negative 1, 0. This would be what you would reduce to some echelon form, right? You'd find reduced row echelon form, and then you do the substitution. But because this is simplified enough here, I would say you just go ahead and, I would say you just go ahead and do substitution from this step. You'll get your free variables, right? You have your free variables here already, basically. It looks like x4, x5, and x7 are going to be your free variables. And then from there, you can determine what the smallest solution would be. Okay, so I think what I'll do is split here and then do the last two problems that I want to talk about in a part 2. So that way, maybe it's a little easier to find which parts you want to study here. So let's just take a small break, and then we'll do 3 and 4 from this problem or from this exam in the next video.